chapter 5 of Stanovich's How to Think Straight About Psychology, the chapter on correlation and causation. So chapters 1 through 4 looked at the types of questions that scientists ask in the social sciences or in psychology specifically. Getting into chapter 5, we start to look at what qualifies as evidence. Well, chapters 4 and 5. So in chapter 4, we looked at case studies and testimonials. Case studies have a place in science, testimonials do not, even though testimonials tend to be more persuasive and compelling than the results from scientific inquiries, which makes it really easy to take that route. But testimonials and case studies can't help us make predictions or state directions of relationships, such as A causes B, or losing weight causes increased mortality. So in this chapter, we'll be looking at the difference between the relationship between two variables, so whether or not there exists some sort of positive, negative, or neutral relationship between two variables. For example, a common one now is whether or not using social media increases depression and anxiety, particularly in adolescents or in Gen Z and some millennials. There is a lot of evidence demonstrating that the more time you spend on social media, the greater the likelihood is that you will be depressed or anxious or have higher scores in depression and anxiety. But does that mean that using social media causes anxiety? Or do people who are more prone to anxiety, are they more likely to use social media? The only way we can test that relationship, that's a causal relationship, the only way to test that is through an experiment. And so what I want to talk about today is correlation and how correlations are limited. And I want to use actual data that has been presented to faculty at Albany State University. So this goes back a few years, but it's been a big theme since COVID. A lot of students are missing classes, and we're also seeing historically low retention rates, which means the majority of students who register as freshmen never graduate. The majority. And that number can be as high as 75% of students who register as freshmen don't graduate within 6 years. It's a pretty tight window. If we look at 7-year retention rate, the number jumps to or drops to about 66%, but that's still pretty high in terms of students who are not making it all the way to graduation. So what does that mean? Well, we've had faculty and administrators address the entire university saying that, look at this data, and I'm showing you just a sample of what was presented. When student absences go up, GPA goes way down. And so I've got two data sets here. So these are students who attend most of their classes. They only miss about 5 classes a semester, so 5 different class periods a semester. Once they miss, and the GPA average there is 3.5, that's excellent. But once they miss 10 or more classes, so we're starting to look at chronic offenders, chronic absenteeism, the GPA plummets down to 0.75, less than 1, and you can't graduate. You don't get credits if you're not passing your classes. And a GPA of 0.75 means that these students are not passing their classes. So I remember having a professor, they're retired now, but they stood up on stage and they were saying, once students miss 10 or more classes, graduation rate drops precipitously. And so we looked at this graph, and it was like attending class. Once they stop attending class, boom, graduation rate drops down. And it was like, I trust that the data says that. But what you're predicting is that we just need to get more students to stay in the classroom or to attend class, and that will solve the failure rates, or the DWF rates is what we call them, but students who don't pass a class, whether they're withdrawn or they just don't get a high enough grade. But the data that they shared was correlational data, and they used that data to make causal inferences. And so what does this data tell us? The conclusion that this professor had was, if we increase the number of students' butts in seats, I'm paraphrasing, then we will solve our retention to graduation problem. But of course, I'm going to critique that and say, not so fast. Couldn't some other variable be responsible for students who skip class and students who do poorly. In other words, might there be some other variable, whether it's having to do with the students themselves, things that are going on in their lives, preparation for college, maybe a demographic detail that does two things. So this one outside, this third variable can help us understand why these students aren't attending class and understand why these students are doing poorly. So notice the attendance and GPA are not directly related. There's a mediating variable that is causal for both. So this is a third variable problem. When we collect data that's correlational, we do not get we can't draw causal inference. All we can do is recognize that a relationship exists, and in this case, as attendance goes down, GPA goes down, so that's a direct positive relationship, but we don't know which is the independent variable, which is the dependent variable, or if both of them are dependent variables that are dependent on some third variable, such as I would argue academic preparation would predict both of those. So this is essentially what I just said, but I have it in slide form here, so you can maybe copy down a little bit of what I said. So I'll go over it one more time. There is a relationship here. Instead of saying attendance, I'm using absenteeism. So absenteeism goes up is the same as saying attendance goes down. And so if we look at absenteeism as the variable and not attendance, then it's a negative relationship. So depending on how we define that variable would change whether it's a negative or positive relationship. But ultimately, a negative relationship means that if one variable goes up, the other variable goes down. A positive relationship means if one variable goes up, the other one goes up too. So another example, if a variable goes down in a positive relationship, then the other variable goes down. So they're always headed in the same direction in a positive relationship and in opposite directions in a negative relationship. So negative doesn't necessarily mean up or down. It just means that the two directions correspond inversely. And then positive relationship means they correspond directly. So if absenteeism goes up and GPA goes down, we don't know which comes first. We don't know if students who are going to do poorly are less likely to attend. So maybe GPA predicts attendance, or maybe attendance predicts GPA. So we don't know the direction of that relationship. We also don't know if there isn't some third variable. And so I wrote two down here at the bottom. Low socioeconomic status might predict that these students who have below average income or even who are at the poverty level when entering college, they may be more likely to work part-time or full-time jobs, multiple jobs. We might look at other family commitments, such as taking care of parents, taking care of siblings, or taking care of children. All of these things would make it harder for them to attend class and make it harder for them to do well in classes. But notice, it's not the attendance that's causing the poor achievement, and it's not the achievement that's causing the poor attendance. It's this third variable. Also, if students simply come in with lower academic preparation, which might say something about their middle school or high school preparation, it could also just say mental capability. And so if we talk about intelligence levels or facility with vocabulary, familiarity with descriptive repertoires in higher education, so just lacking some of these academic skills would make class more difficult and perhaps less enjoyable, and you'd be more likely to skip. And then you would do more poorly on assessments and evaluations. And so again, this is a third variable that helps us understand both of the variables. I just want to go back to this graph because it was presented so emphatically, and this was someone with a PhD who is on an assessment committee who leapt to a conclusion. So what I want to point out is that college faculty who have been trained at the highest level are not exempt from making these mistakes. When we see data pointing in a direction, it's compelling to say, oh my gosh, look what we found. This is the key to everything. But you just need a level-headed psychology professor or data analytics expert or statistician to step in and say, okay, well, wait a minute. I think we're jumping to conclusions here. All right, so I've talked about directionality and the third variable. And I want to talk a little bit more about directionality on this slide. So when we see that two variables correspond, and one of my favorite kind of ridiculous examples is a correlation, a positive correlation between eating ice cream cones and shark attacks. And so I don't have this data, but it has to be the case that the more ice cream cones are sold in a city, the more shark attacks there are. And that might seem random and absurd, but shark attacks are most likely to occur when there are a lot of people in the water, and so the probability of there being a shark attack goes up the more people are in the water, and more people are likely to be in the water when it's nice enough outside to go swimming. Maybe people go swimming all year round, but the greatest concentration of people swimming will be when the weather's nice, and you're also more likely to eat ice cream cones when the weather is nice. There's not a big line at the ice cream shop when it's 20 degrees outside. I'm just saying. And so obviously there's a third variable between ice cream cones and shark attacks, and that variable is weather. The weather helps us understand both of those variables, and their relationship to each other is circumstantial, and so it's not causal, and the direction is irrelevant. But how about these ones? These are two more that I made up. People who have visited an intensive care unit recently are more likely to die. So that means there's a positive correlation between ICU visits and death. Kind of sounds to me like going to the ICU will kill you. So is it that the ICU kills people, or are people who are about to die more likely to go to the ICU? And I think if we look at that logically, it makes more sense that people who are going to the ICU have some urgent medical condition, and because they have a more urgent medical condition, they're probably more likely to die. Think cardiac arrest. Here's another one. Married couples who argue are more likely to get divorced. So if you just listen, put a tape recorder in the kitchen and just count the number of minutes the couple spends arguing, and you could predict who is about to get divorced and who is having a healthy marriage or who won't get divorced. I don't actually know if that's what the data would say. Perhaps you could make an argument that couples who are about to get divorced never talk, so that would be a whole other way of looking at it. But just kind of as a hypothetical example, would that mean that arguing causes divorce, or does impending divorce cause lots of arguing? When we have correlational data, we cannot predict the direction of that relationship. We don't have the right data to make that inference, the directional inference, and ultimately the cause, which brings us to causation. How do we determine causation? Well, I haven't defined correlation outside of two variables that have a relationship with each other, whether it's positive or negative. And I didn't get into the statistics of that, so weak correlations, strong correlations, and that's not the goal of this lecture. It's what the data can tell us, whether there's a correlation or not, what that tells us. Correlations look at existing evidence, look at existing data. So, for example, going to a national or North American education database and looking at achievement rates, statistics of achievement rates, looking at depression and anxiety rates, looking at socioeconomic status, and comparing all of this data. If the data has already been collected, we've already passed the window to draw causal inference. If the data is already there, and if the conditions have not been controlled in collecting that data, then all we get are correlations. We cannot make a causal inference. So let's see. Yeah, so correlations, that sort of data is easy to get because all you need to do is log on to your internet and log on to the computer, get on the internet, look for data, look for different variables and see what their relationship is. But all we can do with that is make correlational inferences or directional, or we can't even predict directional relationships. We can just see if there is a relationship between two variables. In order to draw a causal inference, we need to make a prediction about the relationship between two variables. So I gave the example of the intensive care unit and deaths. And so if we want to hypothesize that going to the ICU causes death or increased likelihood of dying, then we need to treat that as an independent variable. And then I would have to hire, if I was doing this, I would have to hire at least 150 participants. I would send 50 of them to the ICU. And again, these would have to be random participants. I can't pick people who are about to die because the variable we're testing is whether or not the ICU causes death. So I would need to pick 50 people at random without trying to choose healthy or unhealthy people. Just pick them randomly so everyone has an equal likelihood of being assigned that. Send 50 to the intensive care unit. Send 50 to some neutral location that we have no reason to suspect would cause death. I just said the library. And then 50 more people to go about their normal business, just in case sending them to some other location would increase or decrease their likelihood of dying. So again, I'm taking extra caution in these control groups. So that's 150 people, 50 in each location. And then if we're looking at the timeline of it causes death, it doesn't have to be an immediate death. So I said about 6 weeks, and look at how many survived. And if the people in the ICU condition, when they were sent there randomly, so they didn't need to go, I just sent them there. If that group has more people die, and I can use statistics to tell whether or not that number is significantly different from the other two groups. If that is significantly higher, the death is significantly higher than the other two groups, then I can say it looks like the variable of intensive care unit visits has increased the likelihood of death. That's a causal relationship. That's the only way I can say I can make a causal inference. But think about how much time I spent organizing that study and controlling variables and being very careful about who's included. And then I'd have to think through the kinds of participants I would use for my sample and so on. That's a lot harder than just looking at statistics of people who've gone to ICU and those who have not, because in that instance, if I'm picking pre-existing data, I don't know the conditions that cause them to go to the ICU versus not. In the experimental condition, I do know the conditions, or the experimental case, I do know the conditions, and I have organized them as such. That is the only way, an experiment is the only way we can say responsibly and with validity, with external validity, that there is a direct causal relationship between one variable and another. And most people are not willing to go to that length in testing a hypothesis. So if we're only looking, let me go right back to the very beginning, if we're only looking at correlational data, we cannot make a causal inference. In order to make a causal inference about the relationship between absences and GPA, we would have to start off with 150 students chosen at random, and we would have to make 50 of those students miss 10 or more classes for no other reason than we made them miss 10 or more classes. And then another group, we would have to say, like, you better attend more, or you better miss fewer than 5 classes. And then another group, just keep doing what you're doing. So these are multiple controls, and then see if GPA is affected. In that case, if we did a controlled study and saw a change in GPA, a significant change in GPA, then we could say there's a causal relationship between attendance and grade point average or retention, which is what the original topic was.